So today, open up with something easy. That's always nice. So vertical and horizontal lines. We talked a little bit about these yesterday, about the directions they go, but not much as far as the equation stuff goes. So if you have a line, I'm just going to copy over this in a color because that kind of blends in. There we go. So if I start here and I go to the line, I go left 1, 2, 3 on the x-axis. X equals -3. That's it. There is nothing to calculate. There's no other things to find. If you see a vertical line, count over to the left or right to where it's at, find that value, and be done. And it's going to be the same with our second one. Fastest stuff ever. Okay, how do I get to the line? I go up 1 on the y-axis. Y equals 1. That's it. So whenever you see a horizontal or a vertical line, x equals if it's vertical, y equals if it's horizontal. That's it. Recognize and go. Okay, so now let's get a little deeper than that. All right, parallel versus perpendicular. Okay, the slopes, the m values, the numbers that are in front of our x of parallel lines are always going to be equal, the same. Same sign, same number, same everything. But if they're perpendicular, and again, let me draw a little picture with these. So parallel lines, again, are the ones that never cross. Perpendicular lines, we'll draw a picture of them too here in a minute. Are negative reciprocals. You're like, okay, wait a minute. What does that mean? Well, first, perpendicular lines are going to cross each other and make right angles. We've seen right angles before. But negative reciprocals mean you change the sign and you flip your slope. Okay? Reciprocal just means flip the slope. So if your slope was 3/4, you'd put 4/3. If your slope was 2/1, it'd be 1/2 if you were looking for the reciprocal. We literally are just going to flip the fraction over. And so when we look at a pair of lines, if we don't have a picture, we'd rather have a picture, but if we don't, determine whether they're parallel, perpendicular, or neither. So if the slopes aren't the same, or they aren't negative reciprocals, then they're neither, because not every line does one of these things. So, our first job is to get these in slope-intercept form. So we want to get our lines, like we were doing yesterday, into y equals mx plus b. If they're not, and these aren't unfortunately, we need to do that first. So I'm going to sound like a broken record for the first couple of these, but that's okay. We got to get y alone. That's the first job. So whatever's being done to y on that side needs to be undone. And with the reminder that we always want the x term to be the first thing after the equals. I don't want to write 5 minus 10x. I'm guaranteeing you it's going to cause trouble. I can't put these together like we mentioned yesterday. It's not negative 5x. This has x, this isn't. They're not like terms. And so once I do, in this case, my 2 steps to get my y by itself, okay, once you've solved for y, just leave it be for a moment. because we got to see what's going on in the other equation before we can answer the question. They both have to be in y equals, except for one case, which we'll see here shortly. So I look at this next one. I'm like, okay, y needs to be alone. Whatever's outside the box on that side, do the oppo. Oh, it's going to get kind of tight, isn't it? All right. We're going to move over this way a little bit. Again, over here, I can't put them together, but they can hang out on the same side. And it just keeps being one step at a time. Okay. Once those y's are alone, now I gotta go and I gotta ask myself the key question. My slope, remember, slope is that m value. It's the number in front of x. Okay, so the ones that I've squiggled around are -2 and -1/2 the same thing? No. Okay, they're not parallel. Now, are they negative reciprocals? Now, this is a little more interesting. So let me make my -2 a fraction. So if I take 2/1 and I flip it, okay, it's 1/2. That's a reciprocal, but did the sign get flipped too? No, they're both negative. Okay? So here, I'm going to mark that in here too. So for it to be perpendicular, your two answers, you've got to be able to take the one answer, flip the fraction, and change the sign. These are close. If this was +1/2 instead, they'd be perpendicular. Because I would have flipped it and I changed the sign. But they didn't. So this one, after all that work, is neither. Sign flips. We're flipping the sign. We're changing the sign from like positive to negative or negative to positive. She's like, Hardy, that's a lot of stuff to go through to get neither. It's going to happen sometimes. And that's also why today we're going to learn about x and y intercepts, because that can make this go a little faster. But I digress for the moment. Okay. Let's play with one more like this. It's a little longer, then we'll start shortening them up some. Again, the goal is always get y alone. So that's a positive 8x. So I need to do the opposite and minus that out. And again, we always want the x first after the equals, because we don't want to get the slope and the y-intercept mixed up. That would not be good. Make sure your signs are going along. Here we're multiplying by 6. You're like, how do I know it's not minus? Because it's not in between the number and the y. It's sitting in front of it. So this first one, 8/6. Hang on a minute here. -8 divided by -6. We don't do decimals with slope. Okay, so that's 4/3. So 4/3x, and 42 divided by -6 is -7. So there's my slope in the first one. So I'm going to try this one more time. Over here, oh, hallelujah, it's an easy one for once. Let's do this before we start. You're like, Hardy, I can do this? You can. We said we want the x right after the equals. Take the sign with it. The 9 is positive, the 4x is negative. I just always want them to look like this. If they're not, I'm going to rewrite them. And this time, I only got one step to get y by itself. If you're not sure on the fraction, again, little math interaction, never hurt nobody. 9 divided by -3. Those look the same to me. They're both 4/3. So these are parallel. Hi. I want to do one more of these because it's weird. We'll be playing up with some of the homework too. This is where I got to use what I have here. You're like, wait a minute, x equals 2 and y equals 2. That's kind of weird. I mean, what am I even supposed to do? So here, if we think about it, let me make a quick sketch. So there's x equals 2. There's y equals 2. It makes a right angle. These are perpendicular. Now let me go a little further here. Whenever you get x equals in a number and y equals in a number, notice they both don't have xa and y. They just have 1. They're going to be perpendicular every time because they're always going to make that right angle. So this is kind of a special case. It's kind of weird. And we'll get to the practice here in a bit. Oh yeah, like soon. And we'll chat more about how are we going to do a perpendicular, since I haven't gotten one of those fully worked out yet. But we will. We will. So get y alone. Compare just the slopes. Notice we're not talking about the y-intercept at all. That'll come back into play here in a moment, though. And we'll do that. So, okay. Let's get back to the graphing part for a minute here. Like I said, we're going to take our time through this. So, our x and y intercepts. Where does the graph cross the x-axis? Where does the graph cross the y-axis? Whatever that point is on each of these. Okay, the coordinates of that point are our x or our y-intercept. So here, my x-intercept, if I'm on the x-axis, oh my gosh, what the heck? I gotta peek over there more often and see what I'm up to. Thank you. Let's try this again. 1, 2, 3 to the left. So I went -3 for x. I didn't go up or down any. So my x-intercept would be at -3, 0. My y-intercept, I go up 1, 2, 3, 4. Now I have to be careful. I didn't go left or right any. So that part is 0. But since I went up 4, that's my y value. Because every time we do coordinate points, we do x and then y. So, x-intercepts have a special place in math. They can be called a root. They can be called a 0. They can be called a solution to an equation. And that's going to make our life easier when we have graphs. So we like that there's going to be an easier part to this because we got enough work to do most of the time. So to find our intercepts, and this is the last thing we're going to do today. To find our intercepts, to find the x-intercept, you set y equal to 0 and you solve for x. So instead of me yibbering and yibbering, let's actually do this in the example here. Actually, let's do it where we can graph it. That'd be even better. So, to find the x-intercept, I'm going to do these separately. We're going to set y equal to 0 and we're going to solve. So I'm going to plug in 0 for y and I'm going to leave everything else alone because I want to solve for x. And yes, you can get fractions for this. It's okay. So I want to get my 5x alone first because we're solving for x. We're still just doing opposites like we're always doing anytime we're solving an equation. And again, if you get a fraction, be okay with it, okay? But that is not your x-intercept. That's the x value of your x-intercept. But the actual intercept is the x value you just found, and we plugged in 0 for y. So whenever you're looking for an x-intercept, the y value will always be 0. And to find the y-intercept, we just flip the order. So we go back in. We start writing the equation when we get to x. Not the whole term, just the x. We replace it with a 0. Straight substitution's all we're doing. 5 times 0 is 0. 0 minus 1 is negative 1. Again, that's not the intercept. The y value of the intercept is negative 1. The x value is 0 every time you're looking for the y-intercept. Once you have those 2 points, you can go to your graph. Now, 1/5 is just a little past 0, so we'll just kind of wing it here. My y-intercept at negative 1 means we're going to go just down 1. You're going to have 1 point on the x-axis, 1 point on the y somewhere. And once you have those 2 points, connect the dots, you're done. That's all we have to do. And so normally I would do number 2 next, but I think I started myself fractions in the back. And we're probably going to come back to a couple of these tomorrow anyway. I'm keeping this at 20 or under. We're going to see how this goes. So let's flip over. I just want to get you a crazy and a normal. And then we'll kind of wrap up today, and then we'll play with it a little more tomorrow. Fractions, yuck. Okay, we're going to fix this real quick. Whatever that denominator is, every single piece gets multiplied by 3. So now we have 3y equals negative 9x. Now, do I need to do this? We're going to find out. Or did I make my life harder? We're going to see. Okay. Let's find our intercepts. So for the x-intercept, y gets set equal to 0. So y, you're out of there. 0, you're in. Ew, this isn't good. Okay. So now, we're not in a bad place. We want to get the x by itself. We're going to do an opposite on whatever's there. And again, we've seen before, we can get fractions. That's not going to freak us out. So I get over here. Again, the negative is not in between. That's negative 9 times x. Let's make sure negative 16 divided by negative 9 decimal. Nope, still 16 over 9. So We'll explain in a minute how to deal with that on the graph. We'll be all right. We just got to keep playing. X equal to 0. Anything times 0 is 0, so that kind of just goes away. We divide by 3. Man, this one's not going to be fun either, is it? Nope. So here's Hardy's feeling about this. Since you're going to have to graph, oops, sorry about that. Since you're going to have to graph, looking at these as a decimal is probably going to be better. So like if I do 16 divided by 9, I get like 1.8. I'm just going to put the decimal above it. Or 16 divided by 3, I get 5.3. Because I don't want this to be hard. So on the x-axis, I'm going to go almost to 2, a little less than 2. And put my dot. On the y-axis, I'm going to go up to a little after 5. 1, 2, 3, 4, 5, and a little more. And get that drawn up. So with these, again, we're just substituting the x and the y and then getting the heck out of the way and letting it do its thing. But we're gonna get some weird numbers. It's gonna happen. All right, should we do one last fraction? Yeah, because I'm already past where I said I was gonna go. So okay, last one, because fractions are not fun. We've talked before about the fractions. To get rid of them, we just multiply them together. And when we distribute through, we just make sure we're using parentheses around our numbers to help us. So 3/4. 12 times negative 1/3. I got to remember the negative. And 12 times negative 2 is negative 24. That's the equation I'm going to work with, because that's just easier to work with in general. I'm going to plug in 0 for y. Now, you may not have noticed this yet, but I'm going to mention it, and it may save you some writing. Whichever variable you're plugging 0 in for is going to make that variable, that whole thing, go away. So here, you can kind of just be like, okay, that whole thing just went bye-bye. I don't even have to look at that now. Because now it's just going to be 9x equals negative 24. Still going to get decimally on me, but that's okay. We'll even go to the decimal here. Let's just do that. Negative 24 divided by 9. Negative 2.7. And again, the y value on the x-intercept will always be 0. It doesn't change. We're going to keep it simple. Y-intercept, x equals 0. Goodbye, x value. You're out of here. And again, it's just a one-stepper, which is nice. We actually got a whole number this time. Hallelujah. Negative 24 divided by negative 4 is 6. X is 0. Y is 6. Give me a dot. X is negative 2.7, so in between here. y is 0. Again, x-intercept x-axis, y-intercept y-axis. And we're good to go. I'm trying to see where my practice packet went. It has disappeared. That's no good. Well, what the heck? Okay, we are going to have practice. I just have to find mine real quickly here. I think I have found it. There it is. Okay, here's how we're going to do this. Yesterday, we only did page 1. Today, all I would like you to do, okay, is page 2. Page 2. Just the back of that page from yesterday. That'll get us in good shape. We'll see if we need some more of the review tomorrow. If we do, we do it. And if not, we don't. So page 2